Frontal precipitation occurs when two air masses meet. Since the molecules in the cold air are more tightly packed, the cold air is heavier than the warm air. The warm air masses is forced up over the cool air. As it rises, the warm air cools, and the water vapor in the air condenses, and the clouds and precipitation result. Warm fronts tend to have prolonged but light precipitation, whereas cold fronts will produce brief but heavy sudden downpours.
In a warm front, a warmer, lighter, less stable air mass moves in contact with a cooler, heavier, and more stable air mass. As the warm air comes in contact with the cooler air, the warmer air is forced off the ground by a denser, heavier air, and this creates a gradual slope to the warm front as it slowly moves along up and over colder air. An approaching warm front can be identified by the wispy high-altitude cirrus clouds. These high-altitude clouds are made of ice crystals and will not produce precipitation. As the warm front approaches, clouds continue to become thicker, and therefore the area of precipitation covers an extended distance. In a cold front, a moving cold air mass contacts a warmer air mass, and as the approaching cold air is heavier, it remains close to the ground level, and the lighter warm air is forced up to rise. The slope of the cold front is steep, and the rising warm air is forced upward vertically. As the warm air rises, it cools and water vapor condenses to create cumulonimbus clouds directly at the front. Sometimes a cold front follows right behind a warm front. A warm air mass pushes into a cooler air mass, and then another cold air mass pushes into the warm air mass. Because cold fronts move faster, the cold front is likely to overtake the warm front, and this is known as an occluded front. At an occluded front, the cold air mass from the cold front meets the cold air that was ahead of the warm front, and the warm air rises as these air masses come together. And occluded fronts usually form around areas of low atmospheric pressure. Last but not least, in a stationary front, the air mass is not affected by other front when a front stays in one place. And this happens when two masses of air are pushing against each other, but neither is powerful enough to move the other. Winds blowing parallel to the front instead of perpendicular can help it stay in place. A stationary front may stay put for days, but if the wind direction changes, the front will start moving again, becoming either a cold or warm front, or the front may break apart.